Welcome to The Explainer. Today, we are diving into a piece of tech that is, odds are, humming away inside the device you're using right now. It's in the cell towers, it's in space, it is literally everywhere, and yet almost nobody knows its name.
So I want you to think about this for a second. What if a computer chip wasn't stuck being just one thing? What if it could be a graphics processor one minute and a high-speed networking switch the next? A chip that could literally rewire itself on the fly to become the absolute perfect tool for whatever job you throw at.
Well, that's exactly what we're talking about today. A true hardware chameleon, one that can change its very structure to adapt to new tasks. And no, this is not science fiction. This is the reality of the Fpga. All right, so let's get to know this amazing chip, this one-of-a-kind piece of hardware that can completely change its function long after it's left the factory. Okay, so we've got the big idea, but what's with the name? You've probably heard the acronym FPGA thrown around, but what does it actually stand for? Let's break it down.
There it is, Field Programmable Gate Array. Now, the magic words here are configured after manufacturing. You see, the processor in your computer has a fixed, unchangeable design. An FPGA, on the other hand, is basically a blank slate of hardware just waiting for instructions. And if you break down the name, it really tells you everything you need to know. Field Programmable means you, the user, can program it wherever you are, not just in some specialized factory. Gate refers to logic gates, which are, the most basic building blocks of any digital circuit. And array, well, that just means there's a huge organized grid of all these gates, ready and waiting to be connected. So, a programmable grid of gates. Got it. But how does that blank slate actually turn into a video processor or a network controller? Well, to get that, we need to peek inside the chip itself.
You know, the absolute best way to picture an FPGA is to think of it like a gigantic box of digital Legos. You've got millions and millions of these tiny, simple pieces that you can snap together in a nearly infinite number of ways to build, well, pretty much anything you can imagine.
So, at its heart, an FPGA really just has three main parts, just like that Lego set. First, you've got the logic blocks. Those are your actual Lego bricks, the things that do the work. Second, you have the programmable interconnects. These are all the pathways and switches that let you connect those bricks in any pattern you want. And finally, you have the I/O blocks, which is how your amazing creation actually talks to the rest of the world. Now, this whole unique, reconfigurable structure, it gives FPGAs two key superpowers that really set them apart from every other type of chip out there. This table really nails where FPGAs fit in. On one side, you have a CPU. It's flexible because you can run any software, but the hardware itself is totally fixed. On the other extreme, you've got an ASIC, a custom-built chip that is screamingly fast at one specific thing, but it can never change. And right there in the middle, that's the FPGA's sweet spot. It gives you the raw speed of dedicated hardware, but with the flexibility to completely rewire it for a new job later. It's a total win-win. And that brings us to their first superpower, true parallelism. A regular processor is kind of like a master chef juggling a dozen different tasks. It's fast, but it's still just one brain switching focus very, very quickly. An FPGA is like having a dozen separate chefs, each with their own station, all working on their own dish at the exact same time. There's no juggling, no waiting. It's just pure, simultaneous power. And then there's the real magic trick, reconfigurability. Let's say a new video standard or a better algorithm comes out. With other hardware, you're stuck. With an FPGA, you just send it a new configuration file, and poof, it literally becomes new hardware perfectly designed for that new task. For any field that's changing fast, this is an absolute game changer.
Okay, so this all sounds great in theory, right? But where are these hardware chameleons actually being used? The answer is pretty much everywhere performance and adaptability are non-negotiable. I mean, just look at this list. The 5G network connecting your phone, the AI powering search results, the advanced safety systems in new cars, medical imaging devices, factory robots. FPGAs are the quiet, unsung heroes making all of it work. Let's get specific. Think about a huge data center run by a company like Microsoft or Amazon. When they need to make their AI services faster, they can plug FPGAs right into their servers. These chips can be programmed to run very specific machine learning models way, way faster and more efficiently than a normal CPU ever could. Or think about that 5G cell tower. It is juggling thousands of video calls, downloads, and data streams all at once.
A normal processor would just get bogged down trying to handle all of that one after another. But an FPGA, it can create a separate, independent hardware pipeline for every single data stream, handling them all in parallel. That's how you get the super low latency that makes 5G feel so instant.
So what's the big takeaway here? Where is all of this heading? Well, as our technology gets more and more complex and changes faster than ever, the role of these adaptable chips is only going to get bigger. This quote just sums it all up perfectly. We live in an age of constant updates and new breakthroughs. Having hardware that can keep up without needing to be physically replaced isn't just a nice-to-have anymore. It's becoming an absolute necessity.
And that's really the idea to leave you with. For decades, the mantra in tech was always faster and smaller. But maybe, just maybe, the next great leap in computing isn't about raw speed. Maybe it's about creating hardware that's as fluid and dynamic as the world we live in. Perhaps the future is, in fact, programmable.